Okay, so I'm not here today just for period 2, so I thought I'd make you this video, and maybe I might have to make 2, we'll see. So today we're doing all of investigation 5, kind of in one big chunk. It talks about the exponent rules and how to use them. So just as a reminder, these are our types of ways to write our exponents. We have expanded form here, we have exponential form here, and we have standard form. There's no standard form for this version because x times x times x is just x to the 4th. I don't have a numerical value for that. Expanded form for the 3's looks like this. There's 5 of them, therefore the exponent is 5. If you multiply it all out, 243. Okay. Don't forget to put the date up here. Today is February 11th. Oh, sorry. Yeah, February 10th. Sorry, February 10th. And the page number, again, my notebook went missing last class during second period, so I think we're on page 44. I don't really know. Check your previous page. Enter this into your table of contents. Okay. Pause the video is necessary, so it doesn't rush past you. Okay, so I have a long list of exponent rules here, but I don't want to go through all of them at one time. So each page I'll go over another rule. The first one is a product rule. I would just enter this into your notebook little by little and do the example that follows. Okay, I'm pulling your examples directly from the homework that you picked up on the way in. So it should look like your homework, and your homework should be very, very similar. Okay, so homework. This is your homework you picked up on the way in, and we're going to work with the product rule first, which is just like the first 10 questions here. Okay, so let's enter and pick one of these questions. Let's just do question 1 together. So question 1 says m squared times 6m cubed. Okay, and our rule says x to the m times x to the n equals x to the m plus n. So I'm going to explain this rule using the expanded form first. So I'll do this first term in red, which can be explained as m times m, and we're going to multiply that times 6 times 3 m's. There's only one 6 there, and there are 3 m's. M times m times m. Now, my commutative property allows me to rearrange things if necessary. So I'm going to rearrange this, and I'm going to put this 6 out here to the front. That way I keep all my m's together. What that means is I end up with, let me reorganize this a little bit, squeeze this in just a tad. Okay, put the 0 there. Okay, so that's my commutative property. It lets me move things around. My final answer, okay, I have a 6. There's my 6. And I have a total of 1, 2, 3, 4, 5 m's. M to the 5th power. Now, this is the expanded form. If I were to use my exponential form and use my rules, I would have, so this is the same question, just written in a different way. M squared, you know what, I'm going to do this in a different color. M squared, wrong color, M squared times M to the 6m, 6m to the 3rd power. And I'm left with having my 6, my coefficient, because there's a 1 here, so an invisible 1 here. So 1 times 6 is 6. And then I have my m, my base number, m, and then 2 plus 3, 2 plus 3. This is the 2 plus 3. 2 plus 3. Final answer, just like before, is 6m to the 5th power. I think this in purple. 6m to the 5th power. Okay, that's our product rule. Okay, let's just do one more example together, just so we don't get lost or stuck. So let's do question number 2. So the first two. Okay, here's question number 2. Okay, I'll do the same thing. I'm going to multiply my coefficients together first. And I'm going to do this in expanded form just because it makes it easier for me to see everything. 8 times 2n's, 1, 2, times 5 times 4n's, 1, 2, 3, 4. 8 and 2n's, 5 and 4n's. Okay, well, 8 times 5, that's 40. Then I have 1, 2, 3, 4, 5, 6 n's. N to the 6th power. Okay. All right. I know I'm going through these rules very quickly. I recommend stopping the video, take about 5 or 10 minutes, and work through this worksheet. Okay, this is the worksheet you picked up on the way in. This is where I'm sourcing all of your examples from. I'd work on the first 10 problems. Okay, they're directly connected to what we just did, the product rule. Okay, pause the video, work on that quietly. Okay, so now that you've worked on the product rule for a little bit, let's do the quotient rule. Very, very similar, except this time, instead of adding my two exponents together, if they have the same base, I can subtract the top number minus the bottom number. Okay, so I'll do the same thing. I'll take a picture of something from the division questions. So I'm going to pick this first one here, number 11. Okay, so this is from your homework, number 11. Okay, and like I did before, I'm just going to expand it out. I want to see all the different parts to this equation. So on the top, my numerator, I have a 3. There's my 3. And I have 3 x's times x times x times x. Okay, that's my numerator. My denominator is an 8 and 3 x's. 1, 2, 3, all multiplied together. So I can do the top minus the bottom. What that basically means is if I have a pair, they cancel out because they make a 1. So this makes a 1, they go away. This makes a 1, they go away. And this makes a 1, and they go away. I'm left with just 3 over 8. No more variables, okay? Because in this case, they all canceled out. Now, I could have written it like this. Okay, I could have written this same problem like this. 3 over 8, because they're not the bases. My bases are these x's. And then x to the 3 minus 3. Top number minus the bottom number. That becomes a 0, and they cancel out. This would still be my final answer. Okay, let's do one more together because I didn't really like this one as much as it could have been. So let's pick a different one. Let's pick number 15. 15 looks good. Okay. Where's 15? There it is. All right. So we'll do the same thing. I'm going to expand this out, and I'll show you how the rules work. Okay. So I have, this is equal to 8 times p times p times p. That's my numerator. My denominator, I have 4 p's. 1, 2, 3, and 4. What you notice is I try and line up my variables together and keep my coefficients in one group. Again, this makes a 1 and they cancel. This makes a 1 and they cancel. This makes a 1 and they cancel. My final answer will be 8 as my numerator. That's on top. The denominators stay there. They stay on the bottom. Okay, I cannot move this to the top because it wasn't there to begin with. Now, again, if you want to use your rules, okay, just like I did up here, numerator minus denominator exponent, I can have 8p, because they're both the same variable, and then my numerator minus my denominator, 3 minus 4. 8p, 3 minus 4. Okay, again, 3 minus 4 makes it a little bit of a strange number. We end up with 8p to the negative 1. Okay, now this one, I picked this one because I thought this would be a good preview into a couple of the rules that are coming. If this is a negative 1, it goes to the bottom. Okay, just like it does over there. These represent the same thing. So if you end up with 8 over p, or if you end up with 8p to the negative 1, either one is okay. Again, before you move on, work on questions 11 through 20, so that way you can get some practice with a division. Things like number 17, where you have a 4 and an 8, you can reduce those. Okay. Keep in mind, if there's no number in front, there's automatically a 1. Okay. Okay, power to power rule. Now, this power to power rule, I wrote 2 different versions of it because this is one with a single whole number base. This is with a fractional base. What it means is you're going to multiply the exponents together. Before we had add exponents together, this time we're going to have multiply exponents together because it's exponent to another exponent. So like we did before, I'm going to pick a problem from here, and then we'll use it as our example. I like question, let's see, let's do question 26. Now, if I write this out in expanded form, and an expanded form I think is extremely useful because it allows you to see what everything is. I have this group, okay, which I'll expand as 5 times x times y times y times y. There's my 5x y cubed, right? And I have 3 of these because I have to do this 3 times. So I'll make this group repeat itself 3 times. Okay. Now if these are just being multiplied together, the order won't really matter. So I can put all my coefficients together. 5 times 5 times 5, I get 125. Okay, you could call that, if you'd like to, 5 cubed. That's just like putting this next to that 5. Okay, I have 3 x's, 1, 2, 3. So I have x cubed. And lastly, this is the one that gets really interesting. I have 9 y's, y to the 9th. Now this is my original 3 here, right? I can have 3 times 3 because I have 3 groups of 3. Okay, that leaves me with 125 x cubed y cubed. Oops, sorry, x cubed y to the 9th. Okay, this should be to the 9th. I'll make this a 9th. Okay, we'll do this one more time. I'll do it fairly quickly. I got about a minute before this video cuts me off. And let's do number, I want something with different numbers. Number 30. So this one I'll put down here. Okay. So I'll expand this out. So again, here's my 6m times m, that's m squared, n times n times n times n, because there's 4 of them, okay? And then I'm going to do that 3 times. So all of this happens 3 times. 1, 2, well, not going to fit, so I'll just shrink them all. See, power of technology, isn't that great? Okay, I end up with, okay, so I have 6 cubed m squared cubed n